structure is reasonable. And then if it's not reasonable, we have to explain why. So the first thing that we're going to do is answer this question. Does it have the correct number of valence electrons, or do we need to, does it need a different number? So this one is 2 nitrogens, so we're going to figure out how many valence electrons a nitrogen needs. We use the periodic table for that. So remember, if you use the second row, that's going to tell you how many valence electrons the main group has. So this block and this block over here, but not the transition metals. So let's see, nitrogen is in the 5A column. So nitrogen has 5 valence electrons. There's 2 of them. So 5 times 2 nitrogens is 10. So this structure should have 10 valence electrons. So if we go ahead and count these up, we've got 2, 4, 6, 8, 10, 12. We count that 2, 4, 6, 8, 10, 12. So this is incorrect because we just said each nitrogen brings 5 valence electrons. This is saying it has 12. So that's wrong because the correct number needs to have 10 valence electrons. I just have to move on. All right, okay, I guess we should stop and say that, so this is a lone pair, that's 2 electrons, and then each bond is 2 electrons. So this is a double bond. This has 2, 4 electrons in this double bond. All right, let's try this one. Let's count up the valence electrons that it needs. So if we go back to our periodic table, hydrogen's over here, it has 1 valence electron. And oxygen has 6. There's 3 hydrogens, so 3 times 1 is 3. And then oxygen brings 6. 3 plus 6 is 9 valence electrons. And then this plus charge takes away an electron. So 9 minus 1 is 8. So if we have, we need to find 8 valence electrons here. So we've got 2, 4, 6, 8. All right, so yes, there's the correct number of valence electrons. Then we move to the next question. Does it have the correct, yes, it has the correct number of valence electrons. Does it satisfy the octet rule? So let's see, let's look at hydrogen is fine. Hydrogen just wants 2 valence electrons. This oxygen has 2, 4, 6. So it doesn't satisfy the octet rule because oxygen doesn't have enough electrons. Let's look at this one, hydrogen. This one has 2, 4. Hydrogen only wants to form 1 bond. So anytime you see hydrogen with 2 bonds, that's a red flag. So hydrogen is also a problem here. It has the right number of valence electrons, 8, but it doesn't satisfy the octet rule. The symbols of the problem atoms are this oxygen and this hydrogen. The end hydrogens are fine. Okay, next one. This is HBr. We need to figure out total number of valence electrons. So hydrogen has 1. Bromine is over here. It has 7. It brings 7. So 7 plus 1 is 8. So we need to count and see if it has 8 shown in the Lewis structure. 2, 4, 6, 8. So yes, it has the correct number of valence electrons. And then let's count if the octet rule is satisfied for the atoms. So bromine needs to have 8, 2, 4, and then it can see all of these electrons, 6, 8. So bromine is satisfied here. Hydrogen, again, if hydrogen has 2 bonds right here. So hydrogen is really seeing 4 electrons. Hydrogen only wants 2 electrons. It's so small. Its outer shell is full with 2 electrons. So this is not the correct number of valence electrons. Or excuse me, it has the correct number of valence electrons. We counted 8, but hydrogen is not following the octet rule. Well, yeah, hydrogen's octet rule. Okay. Let's check. Let's try one more. Okay, this one, this is supposed to be water, so hopefully you're getting familiar with what the structure of water looks like, and hopefully you can just look at this and say, nope, that's wrong. Or we've talked about hydrogen. Hydrogen has 2 bonds. Hydrogen can't have 2 bonds, so again, you could say, oh, that's wrong. What we're going to do is we're going to count the valence electrons first. So we've got hydrogen, 2 of those. So hydrogen has 1 each. So that's because there's 2 hydrogens, they bring 2 valence electrons total, and then oxygen is in the 6A column as 6 valence electrons. So 6 plus 2 hydrogens is 8 electrons, so let's count 2, 4, 6, 8. So it has the correct number of valence electrons, and then we just figure out which ones are breaking the octet rule. So this one is breaking the octet rule because oxygen only has 6 electrons, 2, 4, 6. Hydrogen has 2, 4 here, so both oxygen and hydrogen are breaking the octet rule here. So again, hydrogen only wants 1, this one's correct. Oxygen wants to have 6 electrons, it only has, 8 electrons, it only has 6. The octet rule, it needs 8. Okay, next one. We have 2 carbons and 2 hydrogens. So 2 hydrogens that each bring 1 valence electron in the first column. So that's 2. And then carbon, there's 2 carbons, each of those is bringing 4. So 4 plus 2 is, so 8. 4 plus 4 plus 2 is 10. So we should have 10 in here. So 2, 4, 6, 8, 10, 12, 14. So this one is wrong because they're showing 14 valence electrons, but really we should have 10. Let me count that really quick. Yeah. Okay. All right. The next one. This one looks funny. Let's see what's going on. We have oxygen, carbon, hydrogen, and it's an ion. So oxygen brings us 6 electrons, valence electrons. Carbon brings us 4, so 6 plus 4 is 10. Plus 1 is 11. But remember, if it has this plus charge on the outside, that plus charge gets rid of 1 electron. So that means we're losing a negative charge. We're losing 1 electron. So we had 11 minus 1, that's 10. So let's see if we have 10. 2, 4, 6, 8, 10. Okay, yes, we have 10 valence electrons shown in our diagram, and that's what we need. Okay, are all of these satisfying the octet rule? So look at hydrogen. Hydrogen has 2. Hydrogen wants 2, that's fine. Carbon can see the electrons in all of these bonds. So 2, 4, 6, 8. So carbon has a satisfied octet. Oxygen, 2, 4, 6, 8. So yes, oxygen is satisfied. So oxygen, carbon, hydrogen, they're all satisfied. We have the correct number of valence electrons. This one would be a correct Lewis structure, even though it looks funny. Okay, so this is one that I would practice and be really comfortable with before the test.